Dear all, in this session I will be discussing important concept on universal gate which you can expect in the competitive examination. Let's understand the fundamentals on universal gate. What do you mean by universal gate and why it is called as universal gate? Nand gate and NOR gate are collectively known as universal gate. Why? Because you can able to realize other type of gates, other type of basic gates such as NOT gate, AND gate and OR gate by using this combination. Okay, that is why NAND gate and NOR gate are collectively known as universal gate. Let us inspect NAND gate. NAND gate is nothing but AND gate followed by a NOT gate. This is your output. Symbol of NAND gate is in this manner. A and B are input, then output is A dot B 4 bar. You can able to write A bar plus B bar. This is also another notation by using De Morgan's law. Why do you say that NAND gate is an universal gate? What is your explanation? Look at this. Consider the NOT gate. Input of the NOT gate is X, output must be X bar. Now like this, you can able to make a NAND gate. Two inputs are shorted. Definitely I am able to get the output as X bar. That means X dot X whole bar is nothing but X bar plus X bar. X bar plus X bar is equal to X bar by using the Boolean law. If I talk about AND gate, inputs are X and Y, output is XY, X dot Y, X and Y. Here you can able to make out like this. This is your NAND gate. Then you are performing the NAND operation X dot Y whole bar. Then again you are using a NOT gate by using NAND gate. Then output will be obtained as X dot Y. If I talk about OR gate, now look at this. You have to use, first of all you have to create two complement operation by using NAND gate. See, NAND gate is actually following in this manner. Here output is X bar and another output is Y bar. Then X bar plus X bar dot Y bar whole bar. Then X double bar plus Y double bar, that is nothing but X plus Y. Thus I can say that NAND gate is an universal gate. If I talk about NOR gate, how do you say that NOR gate is an universal gate? So these are the basic gates like the NOT gate, then this is your OR gate, this is your AND gate. These are the basic gate, you know. Now how do we verify these basic gates? By using NOR gate. Look at this, two inputs are shorted. Then I am able to get the output as same that of NOT gate, A bar. So A plus A, the whole bar is nothing but A bar dot A bar dot A bar is nothing but A bar. Likewise I can verify OR gate also. Now look at this. Here you are performing the NOR operation, then A plus B whole bar I am getting. Then again you are complementing this. I am able to get A plus B. Let us come back to AND gate. How do you realize AND gate? By using a NOR gate. It is pretty simple. Look at this. X and Y are the input. Then you are performing the NOT operation by using NOR gate. Then output is connected to NOR gate. Obviously you will be getting the output as X dot Y. That is equal to, see how I got the answer. X bar plus Y bar the whole bar. Applying De Morgan's law, obviously you will be getting the answer as X and Y or X dot Y. Hope it is very clear. So we can conclude that NAND gate and NOR gate are collectively known as universal gate. Now another type of gate, that is called XOR gate. It is also known as arithmetic gate. Please note down this. Arithmetic. Okay, arithmetic gate. GAT. Okay, arithmetic gate. Here the symbol of XOR gate is like this. Inputs X and Y, symbol will be like this only. Then X XOR Y. X and Y are the inputs. It can be written as X bar Y plus X Y bar. Then look at the truth table. Then you will be getting the peculiarity. Look at only at this particular point you will be getting the output. Now let us conclude. The output of XOR gate will be 1 when there are odd number of ones in the input. See, look at this. Here odd number of ones are available. At this particular point also odd number of ones are available. Definitely you will be getting the output. Then you can able to verify the XOR gate by using OR gate, then to NAND gate, then to NOT gate. It is a simple representation. If I talk about the XNOR gate, how do you verify XNOR gate? Look at this. XNOR gate output will be, here you will be getting XOR, correct? No, XOR output. Look at the XOR. XOR will be connected to the input of NOT gate. If I check the output of this NOT gate, I am able to get XNOR operation. This is the notation. Or else you can mark it as A XOR B whole bar, or A XNOR B. Okay, two manner you can able to represent. What could be the definition? Look at this. See, what is output? Output I am able to get only these 2 points. Now the output of XNOR gate will be 0 when there are odd number of ones in the input. That is true. Okay, odd number of inputs. So here, this is your actual output. Look at this. Here odd number of input is there. The output of XNOR gate will be 0. I am talking about 0 when there are odd number of ones in the input. Here odd number of 1 is available. Here also odd number of 1 is available. So this will be output is 0. Okay, I think you are understanding. This is a representation. Here you have to see there is a XNOR operation. See, like this. You can able to verify XNOR by using OR gate and 2 NAND gates and 2 NOT gates. We already discussed in case of XOR gate also. So these are the basic concept. Kindly recall. Now let us solve some MCQ. So first let me show you. There are 12 MCQs are available. So you have to solve it very fastly. Later we'll have a brief discussion. All the questions are based on the previous discussion only. It is pretty simple. If anything new, you can able to update in your diary so that you can recall during the competitive examination. And also don't forget to do the self-evaluation. Now let us have a brief discussion on individual question. Okay, please hope you have answered. All questions are pretty easy. A dash is a circuit with only one output but can have multiple input. Obviously, it is a logic gate. Please select option A. Moving on to the second question. The output is low if any one of the input is high in case of AND gate. It is very clear. You have to recall the truth table of AND gate. Clear? Question number 3. The inputs of NAND gate are connected together. What is going to happen? Inputs of NAND gate. Look at this. It become a NOT gate now. Input is X. Definitely output will be X bar. Obviously the result is a NOT gate. Please select option C or third option. Then you can see another question. The NAND gate is AND gate followed by. So AND gate followed by. NAND gate means like this only, no? So this become a NOT. Correct, no? So we can say that the NAND gate is AND gate followed by NOT gate. Please select first option. Question number 5. Single transistor can use to build dash gates. The answer is AND gate. Please select option 3. For third option. Dash NAND circuits are contained in 7400 NAND IC. You must have familiar this IC. So the right answer is there are four NAND circuits are available in this IC. Third option is right one. Exclusive OR is the logic gate can constructed from dash logic gates. I already explained this when I was explaining that. So you can select the third option, AND gate, OR gate and NOT gate. Third option is the correct answer. Question number 8. Dash truth table entries are necessary for 4 input circuit. For 4 input circuit, how many elements are there? 2 to the power n. Here 2 to the power 4. What is 2 to the power 4? It is of course 16. The correct answer is option C, option D, 16. Now the logical gates are categorized into, there are 3 groups. Okay, 3 groups: basic gates, universal gate and arithmetic gate. Basic gates are examples of basic gates are OR and NOT. Examples of arithmetic gates are XOR and XNOR. Examples of universal gates are NAND and NOR. We already familiar. Who invented Boolean algebra? George Boole has invented Boolean algebra. Option C is the correct answer. Dash is an example of identity law. The example of identity law is a plus 0 is equal to 0 plus a is equal to a. Then question number 12. Combinational logic is used. So what is the purpose of using combinational logic? That is to compute outputs and compute new states. So please select option C, both A and B.